Welcome to our last and very short video on problem solving. Yes, I'm called problem solving hints. So as we've seen before, there's the basic three-step process, the USE or use process, where you want to understand the problem, solve the problem, and explain your result. So here's some hints and guidelines. Hint number one, there may be more than one answer. And that happens a lot, especially whenever you get things that are raised to powers. There may be more than one method. That's, almost always, as they say, there's more than one way to skin a cat, the old proverbial thing. Make sure you use the appropriate tools, and that's not just in the real world where you're using the right tool for the right job, but in the mathematical world, make sure that you're using the right mathematical tool for the right job. Always try and consider simpler, similar problems, right? A big mantra in math is solve a simpler equation, right? Find a simpler problem that is similar, solve it, and it'll help you understand how to solve the more complex problem. Consider equivalent problems with simpler solutions. Well, that's pretty much the same thing as for, really. Approximations can be useful, not so much in a math class, but definitely in the real world. You can, get by with approximations a lot of time. Try alternative patterns of thought. That's a great way of saying think outside the box. And do not spin your wheels. Basically, don't just sit there and try something over and over again that's not working. You need to know when to pull the plug and try something else. Here's an example. Tickets for a fundraising event were priced at $10 for children, $20 for adults. Shauna worked the first shift at the box office, selling a total of $130 worth of tickets. However, she did not keep a careful count of how many tickets she sold for children and adults. How many tickets of each type, child and adult, did she sell? This is a typical mixture problem, we call, because we're mixing two things. We're mixing children tickets and adult tickets together. So you could try trial and error. Suppose she sold just one $10 ticket. In that case, she would have sold, right, $120 worth of adult tickets, which would have been 6 of those. You found an answer, but it's not the only answer. As we can see by testing other values, if she sold 3 children's tickets for $30, then there'd be $100 left over, and that'd be 5 adult tickets, right? So there's a bunch of different answers. So we would need more information to know the actual correct answer. So in addition to the 2 answers we've already found, other possible solutions are 5 child and 4 adults, 7 child and 3 adults, 9 child and 2 adults, 11 child and 1 adult, and 13 children with 0 adults. And without any further information, we don't know which is true. It would probably be closer to, like 7 children and 3 adults if it was a place that, families brought kids, but it might be closer to the 3 children and 5 adults if it's, more of an adult-friendly show. So, but you would need to know more information to solve that one. Find the total possible number of squares on the chessboard by looking for a pattern. So start with the largest possible square. There's only one way to make an 8 by 8 square, and that's by, looking at all of them. And then what's the next one? Well, 7 by 7, right? So 7 by 7, you have to figure out how many ways you can do that. And it says there's only 4 ways to make a 7 by 7. 1, 2, 3, 4. Yep, 4 ways. And then you look at a 6 by 6 and how many ways you can make that, and then a 5 by 5, and then a 4 by 4, and so on and so forth. And pretty soon you'll start to see a lovely pattern. It's 1, and then 4, and then 9, and then 16. And what do you notice about these numbers? They're all squares, right? 2 squared, 3 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5, 6, 7, and 8 squared. You add those all together, and there's 204 total squares on that chessboard. And that's it, guys. That's the last example. You're now done with problem solving.